I don't wanna grow up, I'm a curious kid. The world has 100 questions I can play with. So I'll open my arms and eyes and wonder every day till the day I die. No one really knows why gravity exists.
Yay, thank you for being here. I am Tucker Hyatt, founding director of Wonderfest, the Bay Area beacon of science, and I am quite glad to see you here. Thank you for coming. Tonight's Wonderfest speaker is Dr. Daniel Okamoto. He's assistant professor of global change biology in UC Berkeley's Integrative Biology Department. Go Bears! He also retains a position at his former institution that's at Florida State University. Warmer water there, I think. Dan earned his undergrad degree at the University of Washington, his master's degree at the University of Alaska at Fairbanks, and his PhD at UC Santa Barbara. He did postdoctoral research back in British Columbia at both Simon Fraser University and the Hakai Institute, and then at the far warmer water of Florida State University. Dan and the Okamoto lab primarily study ocean population dynamics, working with communities, human communities, to make fisheries and conservation more productive, equitable, and sustainable. Please welcome, to teach us about zombies of the Nearshore, Dr. Dan Okamoto.
Thank you very much. Can you guys hear me okay?
Yeah.
Awesome. Well, it's great to be here. And somebody asked me before I started to walk through some of the symbols. One of the things that it's really hard to do any science without money and support from people. And so the groups that have supported our work are the two symbols on the left. Those are both from the National Science Foundation. The one on the far left, that's the Santa Barbara Coastal Long-Term Ecological Research Site. It's basically an area where a huge number of research technicians on the water, basically out every day, measuring things, counting things, deploying sensors, measuring the ocean. So then the National Science Foundation, which has provided a lot of the funding for our work. I was at Florida State for 5 years with my team. We work very closely with the Council Haida Nation, which is an archipelago in the northern part of British Columbia, just south of southeast Alaska. The Pew Charitable Trust have funded a lot of our work, as well as partnerships with the Guayhanas, which is the marine park and conservation area in the southern part of the archipelago in Haida Gwaii. And then which used to be called the Queen Charlottes. They gave the name back to the Queen, so good for them. And then on the right-hand side, the Heiltsuk Nation as well, another area where we work in the central coast of British Columbia. I think one of the most important things is science is a process. And it's a process that involves a huge number of people. So I have a pretty large team. We have actually a number of undergraduates that are not pictured here. We train a lot of undergraduates in science. It's a huge part of the mission of our large research institute. And we have this kind of blank space, because we're always filling the lab with new people and turning them out in the world. And so hopefully, if you go out to, say, the Bodega Marine Lab, we work out at the Bodega Marine Lab, and a lot of our students are out there doing experimental work out on the beach, out on the shores, and out in the water. And so that's a huge part. The best part of this work is the people we get to work with and actually generate the science. And some of that is out in the best days are when you're out in the water, in the middle of nowhere, with the opportunity to work with just really impressive people that are dedicated to natural history, so understanding the ocean and have a deep knowledge. Some of these people have been working on the ocean since they were, just little kids. Same funding sources. So part of what I want to talk about is the fact that we are in this time of just immense change. So the ocean is going through a massive warming period, and there's not really a spot that is undergoing more rapid change than where we are right now. This space off the west coast of North America, as well as off the equatorial Pacific, this is the rate, this heat map. The red shows areas that are warming faster than other places on the planet. We are in this hot spot of global change, and it is really reorganizing everything we know about these ecosystems. But it's not just, okay, there's a certain warming rate that's gradual over time. We are in this place of massive volatility. And particularly in our space, off the west coast of North America, again, this is an area that has the most variability. We get these massive extreme events, these marine heat waves. The redder spaces are the ones that we get massive ups and downs. So a certain year it'll be incredibly cold, and other years incredibly hot. And those incredibly hot years are the ones that make the most difference, right? It's not just the gradual change, that's important. But also, what kind of extreme events are we doing, right? It's kind of like us, we get these heat waves, and those are the periods where everything changes. And you know, for a lot of us, we think about ocean warming, we think about ocean acidification, and then 10 years ago, 15 years ago, we thought certain levels of ocean acidification were things of the future. We were forecasting to 2100. And we start measuring some of these things in certain places. We're realizing the extremes that we thought were far off a century from now are happening today. We get these extreme events that are pulsating, that are stressing out these ecosystems in ways we didn't really expect to try to understand now. So these are sensor arrays of both temperature and carbon dioxide dissolved in the ocean water that relates to ocean acidification, and these are incredibly extreme. The places that are hit the hardest are these nearshore environments off the coast that host things like kelp forests. So kelp forests are some of the most productive ecosystems on the planet. Think about coral reefs, you think about tropical rainforests, they can't hold a candle, right? So something like a kelp forest, each one of those little blades on those pieces of kelp, some of them will grow 12 centimeters a day, and you imagine there might be 100 of those blades on each one of those little bowls. The amount of gross material that's produced in these ecosystems is just incredible, right? They're bathing in this just basically giant hydroponic system, so they're able to grow like crazy. They support fish, they support invertebrates, they support basically anything in the nearshore is supported by these ecosystems. And the challenge that we have when we're thinking about global change, the change in these ecosystems, is that we have the change that's impacting these habitats directly, these marine forests, but also the consumers in these spaces. And we're really trying to understand what's the balance between the sustainability of the production in these habitats as well as the consumers that live in these habitats at the same time. What do I mean by that? So this is some of our field sites in northern British Columbia. You can see in the shallows those kelp forests, and just below that, these consumers, the little urchins, the little herbivores. Many of you go out to the intertidal, you can see some of these out here. And this is what it looks like in a lot of the habitats that we work in now. It's scattered with consumers. Now these animals are native, they belong in these ecosystems, and yet very quickly they can go from these kind of habits, from the habitats I was just showing you, to those that are covered in animals that eventually become pests because they are so abundant in these spaces. And everywhere I've ever worked, these organisms have this capacity to take over ecosystems, just like an insect pest, again, native, but out of balance in many of these habitats because they are voracious. Now these ecosystems have been changed not just in the recent past, but over the last couple hundred years with massive amounts of overexploitation. Right? We think about abalone that have been harvested historically over the last century, many of these species to the brink of extinction. Things like Pacific herring that were taking out millions and millions of tons out of these ecosystems, sometimes for fertilizer, for oil, for other purposes, as well as things like the hunting of near extirpation, local extirpation in our case off the coast here, about 100 to 200 years ago, depending on where you are. And that has consequences, right? The consequences of these legacy effects and the current day overabundance of many of these organisms on other species that we care about. This is an abalone. These are abalone they are a giant walking ball of muscle. They need to eat like crazy because they are just metabolically demanding. If they don't have any food, they eat kelp, just like the urchins. They basically start starving to death. I'll get into that in a little bit. The same thing, Pacific herring and a lot of other fish utilize these habitats. So herring come to the nearshore and they lay their eggs on the vegetation. That vegetation is incredibly important, not just for those herring, but also for the humans that consume those. This is a traditional food, a cultural food for a lot of coastal people up and down the coast. We used to have massive herring populations in the San Francisco Bay Delta, as well as all over the coast here. There are a few relic populations of large spawning events across the coast. And I'll show let's see if I can get this video to play. So this is a spawning aggregation of Pacific herring in a kelp forest. All that white stuff is herring sperm. So, and sometimes we get to go diving in that, which is an interesting, awkward experience. But then what happens is you look underwater. Those are floating kelp forests, giant kelp forests in British Columbia. And these are large spawning events that draw in huge numbers of animals. And then you go underwater, and this is what it looks like. Just the amount of biomass that comes from the ocean to spawn every year is just this incredible gem. And that's feeding eagles, birds, sea lions, everything. You'll see a sea lion swimming around in there in the background. But of course, urchins that I was just showing are also an incredibly important and lucrative dive fishery. So anybody, how many people eat uni? So uni is the urchin roe. You go to a sushi restaurant, you'll find this as a delicacy. When you get it fresh from places like Santa Barbara or British Columbia, it is incredible. If you get a bad one, it's really gross. So you'll be put off by your first bad experience. But that's what it should look like on the bottom right, and that's what it looks like when they are in these areas where they've eaten themselves out of house and home. They basically utilize all that energy that goes into that uni product, their roe, and it's basically, we call them a zombie urchin. There's nothing left. They've eaten, they've digested, they're emaciated, and yet they can persist in this state. If we stopped eating for a couple of weeks, we'd be in a pretty bad shape. These animals can sit there and hang out for decades, centuries. There's very little protein, and they metabolically depress themselves. We'll get into that in a little bit. Northern British Columbia, Haida, there are documents from 1877 talking about how these animals were everywhere. This was post-extirpation of the local extirpation of sea otters, which was the dominant predator in these systems for these urchins. So if you go up to Haida now, most of these habitats in the subtidal are dominated, in the rocky reefs are dominated by urchin barrens. And that's because, again, of the loss of these animals that were these voracious predators that were also carefully managed by indigenous people in that space. They would actually, sometimes kill them and put them out like scarecrows to protect their shellfish beds because they eat the same things that we like to eat. Right? So we get habitats that look like this. And part of what we do from a science perspective, that's really interesting. Why can you have an animal that can persist for decades or centuries in a space where there's basically no food? So we have a science lab on campus that studies the human physiology of athletes and how does that relate to nutrition when you put them under stress. What happens? We do the same thing but with animals. We can do a lot more because we don't have to deal with the same permitting restrictions of putting people under stress. So we put these animals in these kind of little torture chambers and we measure what's their metabolic rate, right? What's their activity levels? How do they respond to stressful conditions like food deprivation, starvation, and how quickly does that happen? We can measure this in the field, we can measure it in the lab. And what these animals do is they basically suck down all their energy reserves and then they go into a metabolically depressed state where they basically just shut themselves down. Again, like us, they have muscle, but they have very little of it, right? Most of their body is lipids, fats that don't actually take that much energy to consume. And we have a future ocean simulator at the Bodega Marine Lab where we can put animals under stressful conditions and measure what happens over the long term. Measure future conditions, future temperatures, ocean acidification. So if you guys ever happen to visit the Bodega Marine Lab, you might see our facility out there. So this helps start to explain, okay, why do we get this scenario where these animals can persist for almost forever? Because all they need is this little thing, like a little piece of seaweed to come by, a bit of kelp that feeds them every month or so, as opposed to, you'll notice the little abalone that's trying to catch a little scrap of some of that food. And they do the opposite. They have to eat all the time, just like us. So they'll wander around and basically, because we get these habitats where all these animals, the urchins are basically in the subtidal zone. If you go out to the intertidal here, you'll notice that there's not a lot of urchins. They don't like wave action, they get smashed off, and the only place you'll find all the seaweed is in the very, very shallow parts of the intertidal and shallow subtidal. That's where these abalone are crawling out of these habitats and they're getting eaten by land-based predators at the same time. So they're really risking everything just to try to get a scrap of food. Now, this is something that has been in existence for years, decades, well before this global warming problem, partly because of the loss of the native predators from these systems. But we've been having, let's see if I can get this to play, maybe. We've been having, how many people have heard of the warm blob? So about 10 years ago, we had this massive marine heat wave that just came and took over the Pacific. And this was a real wake-up call for a lot of us on the West Coast, because we had been thinking, well, we have a pretty stable ecosystem. You look out on the coast, you see these big, big kelp forests. And this was a real challenge for us. And part of the reason why this is a problem, I don't have too many figures like this, but I kind of want to just illustrate what happens to a consumer like us when things get warmer. Now, we are endotherms. We try to keep our body temperature the same. But as things get warmer for ectotherms, meaning their body temperatures are the same as what the ocean is, as things get warmer, rates of chemical reactions go faster and metabolisms go bonkers. And so those animals, the faster the metabolism is, just like your little teenager that's running around trying to eat everything in your fridge and your cabinet, like I was when I was a kid, that goes crazy, right? And they all of a sudden have this massive appetite during those periods. Same thing with ocean acidification. It's incredibly stressful for a calcifying organism to be in acidified oceans. They have to start eating like crazy just to maintain their basic functions. And so this balance between those animals that want to eat all that food, as the ocean gets warmer, you get things that look like this. All these animals that previously could coexist with all that production because they're getting enough to eat, things get warmer, they have to eat a lot more. And this is not just in these kelp forests. This is happening all over the planet. Things get warmer, fish, we get mollusks, all these things have higher metabolic rates and they have greater demands, which means they have to eat more or grow slower. So we're seeing fish all over the planet actually getting smaller and smaller and smaller at the same time. These animals respond by eating like crazy. The other thing that happens is that we get lots and lots of these guys coming out of the plankton, meaning new little babies coming into these systems because we get a shift in the ocean conditions. In some places that's really beneficial, meaning these little animals, these are about this big, they come out of the plankton as little floaters at about the size of a sand grain. And if you go off the coast of Northern California right now, you'll see just the whole benthos is blanketed in little tiny baby urchins. And we've seen a shift ever since that warm blob. Every year there's a new cohort of little tiny juveniles that is just blanketing this ecosystem. And we're getting different trends in different places. So Northern California versus Southern California. In Southern California, that warm heat wave has been really bad for a lot of these animals. These are temperate species, and they've seen a major decline. In Northern California, where things are a lot cooler, that warm water is put into this zone where actually this is quite good for them. We've seen this major shift. So this response of ocean-based climate change is going to have very different impacts if you're a temperate species, if you're on the warm side versus on the cold side. We're on the cold side, and this has become a real problem. Yes?
How do you feel about questions during your presentation?
Yeah, please go on and ask questions throughout if you guys are interested. Yes?
Your title is Zombies of the Nearshore.
Yep.
So these urchins you're referring to as zombies because of their eating habits or because they're not as functional as most?
Yeah, well, so we actually had a paper that got reviewed, and somebody didn't like we anecdotally called it Zombies of the Nearshore. And they said, well, they're not dead, so they're technically not zombies. But they have almost nothing to them, and they will eat everything in sight. And as soon as you put food in front of them, they will just gobble. They eat the tanks that we have them in the marine lab, so they are basically walking dead.
So then what happens to them?
As soon as you give them food, they come back. They reanimate. It is an amazing, we're trying to work out how to study this from an aging perspective. Like, why can these things live forever from a cellular perspective? And if anybody's interested, this is just another kind of, there's a theme here of sperm floating around in the ocean. So these are animals that are spawning. That's a male with the white and a female with the yellow. This is up in Heidegweiber's, a mass spawning event. And we call this, their reproductive strategies, we call it spray and pray. They put the eggs out in the ocean, they put the sperm out in the ocean, they hope it works. The point is that they put out millions and millions and millions of eggs for every female, right? And that all floats around in the plankton. And if the stars align, that means you can just get massive numbers of new individuals coming out of the plankton, settling down and turning into new adults in that ecosystem. So this is why this can happen super fast, right? So on the top, That's one of our kelp forest habitats that we survey every year in Southern California. That little dot is our 25-foot dive boat. Same dive boat, same plots, little points, I'll get to you in a second. And those are the same exact GPS points from our underwater survey areas. The top is about 6 months before the one on the bottom. This is an explosion of urchins that just completely devoured that forest on the left-hand side. Question?
Yeah, so can you clarify what Haida-Gwaii is? Because I've seen it at least twice now in your presentation.
Yeah, Haida-Gwaii is an archipelago just on the southern end of, it's just south of Southeast Alaska in northern British Columbia. So this, I had a map here somewhere. That square up there, so that's British Columbia, we're down here in California, and just outside the map is Alaska. So it's an archipelago, called it Galapagos of Canada, because it's just incredibly diverse, beautiful land.
Yeah, and you got a pointer on that.
Oh yeah. I'll show that map again. But yes, Haida-Gwaii, it used to be called the Queen Charlotte Islands, and now it's, again, they gave it back. So this is what a purple urchin, we have different species. Purple urchins look like in these barren habitats. That should be full of that yellow, uni, yellow gold. And these animals, they just walk around like zombies eating everything. We've done a bunch of it, yes.
How do they eat?
They have a little jaw that basically has 5 little teeth, and they basically just scrape. They have a bunch of little tiny, we call them tube feet, and they have a little glue on the end, and they basically walk food from wherever they catch it down to the mouth. They chomp it up, and then they poop it out. Yeah, and they again, they've been eating our tanks, they eat everything. Yes?
Do we get the roe or the uni from both the male and the female?
Yes, and this is why purple urchins are not nearly as marketable or good. As soon as you break them open, they start oozing their gametes. So you start seeing the sperm and the eggs. The red urchins, the big ones that I was showing that live for decades, centuries, those ones seem to hold together really well, and you can't really tell. People don't really like eating a thing when they start, oozing their gametes all over you. So this is just an example of a PhD student, Maya, and my postdoc, Sam, have spent like 3 years just doing experiments, trying to understand how does ocean warming and ocean acidification affect the small little larvae of these animals, the adults. We've done a ton of work, and we've basically started to understand why we're seeing the population trends that we're seeing in northern and southern California. A lot of it has to do with reproduction, strategies, development times, and a lot of it impacts booms and busts of these animals. The other thing that's happened at the same time is we've seen these major changes in what's going on with the urchins themselves, their metabolism, how many new babies are coming out of the plankton, is that we lost this animal. This animal was wiped out by a disease pretty much all over the West Coast. It's now starting to come back. You can go up to Mendocino and see some of these sunflower stars. That halo is urchins running away. We actually used to use these animals to collect abalone and other animals because they would force them to run out of the cracks. There's putting out some sort of pheromone, something, and they are such voracious predators. They'll eat a couple urchins a day, but the way they eat is they put out their stomach and they basically slowly digest it it's like you guys remember Star Wars? There was like the big pit the guy falls in, and it takes him 10,000 years to get digested. It's kind of the same idea. So if you're an urchin, that's a really bad way to die, right? And so we lost these animals, and we saw a big explosion. These are basically predators of both the adults and the juveniles, and we saw big explosions of the populations because there were no longer predators, as well as an increase in the number of new babies coming out of the plankton. Perfect storm of a problem. At the same time, that warm water that's really good for urchin larvae, that's also really bad for their predators, is also really bad for their food supply. So the kelp was negatively affected by that ocean warming, decreases nutrients. This is a cold water species that really doesn't like that warm water. And when we got that blob, we got this massive loss of the kelp forest. On the left-hand side, we get the wipe out of that kelp forest because a lot of that kelp just directly was being impacted by that warming event. It was then grazed down by an overabundance of sea urchins, and the abalone started starving. So you're basically probably not going to be able to harvest abalone for at least another 10 years from the north coast, if not more. That might be closed forever, yeah.
one question. So you mentioned in Southern California, the ocean warming made it bad for the urchins. It's bad for the kelp too, but is the overall effect on the kelp positive?
It's interesting because in Southern California, here we have bull kelp, which is a temperate species that doesn't go into Southern California. It stops at Point Conception. In Southern California, they also have giant kelp, which is macrocystis. That goes into Baja. And turns out that has been able to hang out even during those warm years and do fairly well. So a lot of things, we saw tropicalization of Southern California, tropical seaweeds, tropical sea urchins, all coming up during the blob event. And then as soon as it relaxed, those all died away and things kind of went back to normal. But the urchin barons that we used to see in Southern California haven't really come back. And a lot of that is because we're seeing this more warming. These are cold water species. So I think one of the important things is the context of where you are and the impacts of global warming are very, very different, right? So some places are winners, some places are losers. Kind of like why Canada is all of a sudden growing Pinot Noir. So we saw this huge loss of these kelp forests, right? And they've not come back. And there's a lot of efforts at restoration. And so you get a lot of habitats that look like this. There's a little bit of kelp forest in the shallows, and then in the depths, there's very little because of this increase in these animals. So the real question, I could talk all day about the science that we do, and that's the kind of fun part that the students get to be involved in. But I have a 5-year-old, and we try to tell her, okay, we can't just I used to just throw into rooms and throw grenades into a room and tell them there's a problem and run away. What do you actually do with a problem, right? Well, it's not very satisfying to just say you got a problem, you guys go deal with it. So a lot of what we've been doing, we started a lot of this in Haida Gwaii in British Columbia, up there, is to work on, well, what are solutions to a lot of this space, right? We can't just assume that we're all going to decarbonize, we're all going to solve this global warming problem. It's here and it's here to stay. The best we can potentially do is think about, next generations. But there are things we can do now to mitigate a lot of these solutions and to figure out, are there ways to make ourselves more resilient to a lot of these changes? So we're going back in Haida Gwaii and a lot of these places along the coast. The sea otters were hunted to near extirpation, local extirpation in a lot of spaces. And that was, somewhere between the late 18th century and the early 19th century. We saw a lot of them disappear. At the same time, we saw this increase in urchins because of the lack of predators, and also an increase in things like abalone that these sea otters also like to eat. Commercial abalone fishery came and wiped out a lot of the abalones, and they've been recovering in places like Haida Gwaii now. But there's a couple of big projects that are focused on this question of well, how do you generate solutions? One is focused on a community-based project that's focused on kelp forest restoration directly, and the other is trying to understand, as we start to recover these sea otters, how do we generate mitigation and management strategies, because these animals were managed by indigenous people for millennia. And so the whole point of this work is, rather than having this giant top-down approach where the government comes in and tells people to do stuff, this is really a Haida-centric, Haida-led project where researchers like myself can come in and basically consult, work on these projects, and do the science that's necessary for them to succeed. And the whole point of that is this was supposed to be focused on a lot of the Haida ethics and values, right? A lot of what we do, you guys have heard about wolves coming back to Yellowstone at the same time you're trying to recover some other population. We've got a scenario where we've got an endangered abalone, we've got commercial fisheries, and we're trying to think about restoring the southern sea otter, the northern sea otter in this case. This one's recovering naturally. But all of these things are connected. You're trying to do a management intervention. Do you really want to recover a predator and its prey at the same time without thinking about how they might affect each other, for example? So interconnectedness, places like Haida Gwaii, they have not just laws that govern specific entities, but actually laws that are based on ethics and values, right? So things like balance, interconnectedness, respect, responsibility, giving, receiving, or reciprocity, and the seeking of wise counsel. And these are deeply rooted in Haida ethics and values, and the whole point of this is that the focus of these restoration efforts, or mitigation efforts, or management efforts, should be based in these values associated with Council Haida Nation. Yeah.
I've never heard the term Haida before. That's a Native American, is the word tribe?
Yeah, it's basically in Haida Gwaii, those are Haidas. Then there's also Haida in Southeast Alaska, in places like Metlakatla and other areas in that area. It's a group of indigenous people that have different bands in different regions. In this case, Haida Gwaii is a First Nation. They never signed treaties, unlike in the United States, and so there's actually a big reconciliation sovereignty set of cases happening right now. Yeah.
I just want to point out that Haida Gwaii was the seat of protests and rebellions in the 80s that led to a restructuring of the relationship between First Nations and the central government in Canada.
That's right.
And it's it was a pivotal moment in Canadian history and First Nation history.
Yeah, and so this is actually really important because the areas we work, Parks Canada, we don't really think about it as a park. The southern half of Haida Gwaii is where there was a big logging encampment, and they basically protested and were able to shut down the logging operations, and that established Guayhanas, which is this large natural conservation area that's co-managed by Council Haida Nation and the federal government in Canada. And this is where most of that work is basically taking place. And it is a very different model of co-management than we would have here in the United States, but a lot of people looking to it as a model for how things could be done, even though there are different legal structures. And that's a whole different set of talks. But it allows for the leadership to do this kind of work that I'm going to talk about right now. So I'm glad you brought that up.
I just had can you go back to the last slide where so these symbols are they
Each one of these is a different animal. So you think the top left is an abalone. On the right, you've got a Pacific herring. That's a frog, a tree. I can't remember which is it. A pigeon guillemot. I can't remember.
Puffin.
Puffin. Yeah.
Looks like a puffin.
There are puffins. But the point is that these are symbols that were generated actually when Guayhanas was generated. The foundations of the principles of that area, that conservation area, is founded on Haida ethics and values as well. So these actually come directly from the foundations of Guayhanas. Yeah. And there's I'm not an expert on the governance structures. You can talk to a lot of our collaborators and colleagues in that space. But because of that, there's a lot of opportunities for generating partnerships and collaborations with researchers like myself that get invited into some of these places to really have an opportunity to contribute. So this is a collaboration with Haida Fisheries, the Council Haida Nation, as well as Parks Canada, the Canadian federal government, and a bunch of university researchers to focus on how do we generate restoration efforts. And so again, Haida had lost access to abalone in a lot of these spaces because of the commercial overharvesting. That is recovering now, but they're still in this endangered space. And now sea otters have just recolonized part of the island. It's a handful of sea otters that are transforming these ecosystems. But knowing that also one of the losses was in a lot of these places, because of the loss of things like giant kelp, there's a loss of access to traditional harvest for Pacific herring that had also been overfished themselves directly, but also losing habitats. So what you'll see on the left-hand side there is that's a blade of giant kelp that's covered in herring eggs, and that would be harvested and eaten. This is a kind of a traditional food in Haida Gwaii, but it's also sold, historically had been sold to Japan as well. So this is the southern half of Haida Gwaii. Again, that's Haida Gwaii, this is Guayhanas, and there's a strict protection area, but what we were able to do was work with the urchin harvesters in Canada to come and say, you have exclusive access. We're going to set up an area where we're going to allow you to harvest and try to figure out, can we restore these kelp forests by utilizing the urchin harvesters that are coming from other places and allow them exclusive access. So there's the Archipelago Management Board. They approved this, and we have basically this reciprocal relationship with the urchin fishery, and this is monitored by Haida Guardians. So we have a 3-kilometer coastline, spread of coastline that we were going to restore, in an area that we monitor in contrast, as an area we didn't do anything to see what the contrast was. And these are all massive urchin barrens. So there's a Haida traditional fishery where they were harvesting urchins, a large commercial fishery that's taking a huge amount of these animals out that were being harvested by hand or some of them being smashed. So this is an aerial image from a drone. We were doing a lot of dive surveys in these areas as well. These are areas before the restoration, and there's no kelp in that space. These are dominated by urchin habitats. This is just one snippet, right? That's in 1 year after the restoration effort where we started removing urchins. And this is, again, 3 kilometers of coastline. This is millions of urchins being removed over a course of a couple of years. And it was largely successful. So this is a cartoon that one of my students wrote. We just had a paper kind of describing the whole process. And we start with this area where we've got urchins that are these zombie urchins. They're unfit for harvest. The people ask, well, why don't we just harvest the animals? There's no commercial value to the urchins in these urchin barrens. There's nothing to sell. Nobody wants to buy that. It's gross. But we start harvesting the few that are at the very top where there's some food, and then the rest are removed by haida divers as well as the commercial urchin fishery. And what happens is the animals that are left in these habitats, after it only takes a few months for these animals, once they start getting fed, to regrow that uni. And now you've got a space where, because you've got that activation energy, you've removed the dominant consumer, the kelp comes back, and all of a sudden those animals that are left in those habitats, they are full of uni. And so the model here is that they can start to be a sustainable fishery that that the harvesters have access to, as long as you can stay on top of it. Yes?
So this would be the natural way of restoring the habitat of the uni, correct?
I'm not sure I would call it natural, but it is the logical way, because it's manual removal. A lot of it, like, the hard part is most of those animals are not marketable, so you have to either kill them underwater or bring them out of the water and put them in the compost. Right. But yes, but it's really expensive to pay urchin harvesters to do this. It's a lot of work. Yeah.
That's why my follow-up question is, can this be replicated in in a laboratory setting where it's like, we can cultivate the same sea urchins so that we can have it for directly to consumers?
Yeah, so people are trying this. There's this group called Urchinomics, and it's a Japanese company. And the hard part here is the amount of real estate. You can do that, but we've got hundreds of kilometers, hundreds of miles of coastline that are dominated. And there's some economics to deal with in terms of scale. If you, for example, you want to protect a shellfish bed, 3 kilometers of coastline, the relic population of abalone, that is a great approach. So this is the idea here is you can harvest the animals in nature. But I'll get to why this is a bit of a problem. We can actually trace what they're eating using chemical. We have students that are basically doing a bunch of biochemistry to look at, you are what you eat. We can measure what's in their gonad, what's in the uni, and say, yes, they're eating kelp and they're eating this nori species and they're eating other things. It's working, or it was. And so we go from this on the top left to this marketable quality uni. And the great thing is we can harvest these animals, we can bring them back to the community that has lost access to a lot of this traditional food resource, do a lot of trainings, provide the food. It was a really cool cultural moment as well. And it was, again, it was Haida-led. We were providing some scientific assistance, but a lot of this work was led by Council Haida Nation. The problem was we had another marine heat wave. And it turns out, let's see if I can get this to play, there we go. This is the same restoration area. That's all bare rock. Notice how there's one urchin there, there's one urchin on the top of that rock. The marine heat wave comes through, it reduces the productivity of the kelp populations. It doesn't take very many urchins to graze down a reduced low productivity kelp forest, and now we're kind of back in this state. So we've got low density of urchins, and we don't have any kelp left. It actually looks worse than when we started because of that interaction, right? This is a climate change problem that is a direct result of the interaction. Now, if we have another set of good years, maybe we'll get good kelp recruitment, but it doesn't take very much because the new baby kelps are very small. So those urchins that are eating, they don't need to eat very much to suppress the new growth coming up.
How much are you talking about in the difference in water temperature?
Few degrees. Yeah, it doesn't take very much. We see that tipping point pretty quickly, and because again, it's a cold water species that requires that. And the bull kelp is an annual, so it has to do it every year.
Is there any chance that kelp could be resistant to the temperature, or to
People,
accommodate it?
yeah, well, there are different species. People have been trying this idea of can we generate thermally resistant strains? That's possible, but more likely what you'll see is, warm water, more tolerant species rather than individuals. But who knows, right? We're in a different world. So we've got this space where we've got some of these areas that are dominated by urchin barrens. We've got them here too. And one of the things that's been happening, again, I noted this in southern part of Haida Gwaii, a few animals somehow found their way 100 kilometers offshore from the areas where they had already been recolonized and found themselves in Haida Gwaii. How they did that is that's crazy. But they're making babies up there and they're eating little abalone and they're eating urchins. Now, we went, as soon as we heard this was happening, we started diving. This is 2 years after the animals. This would have been bare rock, and all of a sudden, all it takes, these animals had wiped out all those animals, all the little urchins, within a year of a bay, right? But it takes a while within that bay. These are all perennial kelps now that are starting to choke out the annual bull kelps. And this is an area where, in the presence of the dominant predators, where they're removing the urchins, now we get spaces where this is the area that is quite resistant to those annual fluctuations in temperature because we have predators that are removing a lot of those consumers. The problem is they also removed everything that we like to eat, which is abalone, which is urchins, which is gooey duck, which is crabs, right? You're getting the idea there that there's this competitive effect because traditionally they had been managed through different areas to protect certain shellfish beds. So we had a project to get together all the experts we knew about sea otters to say how can we try to understand what might happen in the future? And so this is where we're actually doing very similar things now. Can we learn from the areas where sea otters have been restored or had recolonized, see what happened in those places, and are there lessons that we can start to learn? And this is what happens. This is all those little red points. So this is Haida Gwaii, and all these little points represent dive survey areas where people have been monitoring what's happening with urchins, for example. And all these lines represent, this is the otters going up. That's what happens with the urchins, right? They just wipe out, they come in mass, they wipe out a lot of the urchins. Same thing with gooey duck. Anybody gooey duck? Really delicious. It's really expensive. Valuable dive fishery, same thing happens. The gooey ducks get hammered, but they get to a fairly, actually, much less equilibrium point. We think that there's still this capacity for sustainable fisheries with this dominant predator. And we can work to envision what the future would look like based upon what has happened in other places in some of these areas, going from urchin barren habitats to areas with fewer shellfish, but still with kelp habitats in those areas. The problem here is that a commercially viable space? It really creates conflict between the fisheries and that have a right to be there and some of the predators that also have a right to be there. And so this is a delicate balance because, again, there are no management options for sea otters. In Canada, you can't go out and shoot a sea otter because there's too many. In Alaska, in places they've got the Sitka tribe, for example, has the right to harvest because there's thousands of these sea otters and they can manage in certain ways. You can read about the complexities of that from the U.S. Fish and Wildlife Service. But we can build models. Half of what we do is mathematical modeling. We can try to forecast what we think would happen under different scenarios to help fishermen try to plan and try to generate management scenarios. So this is part of what we're trying to do now, is try to work with harvesters to say, if you were to do this off the coast of California, what are the challenges? There's a lot of resistance from the urchin harvesters' fleets, from the crab fisheries, because that will destroy a lot of their livelihood, or has the potential to destroy a lot of livelihoods. We work with a lot of communities and social scientists to try to say, what's the value of a lot of these things that might be lost? This is an abalone summit we had in Haida Gwaii because sea otters love abalone. It's also the thing we were trying to protect when we're restoring kelp forests. So you can try to restore kelp forest for abalone so they have something to eat. But if you restore the predator, you might restore the kelp forest but lose all the abalone. And so for the indigenous people across the coast, this is a really important cultural species. So for this species, this is incredibly important. And so we have some new projects with a group like Shia Band of Indians and Bodega Marine Lab and Scripps to try to understand how can we start to help restore the red abalone on this coast by understanding their genetics, their brood stock, and think about captive breeding, because we're in a really dire strait in this space. Yes?
Are there 3 or 4 kind of abalone locally, well, if they weren't all almost hunted to extinction?
Yeah, traditionally there would have been 7. But really, it's the red abalone was the one that has really made a dominant recovery since the overharvest, and that was the one that was traditionally harvested. I mean, has been harvested for the past decades until 2018, I think, is when they closed it. I can't remember the exact date, but yeah, now none of them are open for any sort of harvest whatsoever.
What? Go ahead. What keeps the sea? Oh.
Sorry.
What do you do with the sea otters? Can you eat them, or, I mean, they're just predators, or where?
I do nothing with them. So, there's the Marine Mammal Protection Act, which basically says unless you have some specific carve out, you can't touch them. And so in Southeast Alaska, it was a long battle, legal battle, to get a carve out for the Marine Mammal Protection Act so that some of the tribes and the native corporations in Alaska could do some traditional harvest. So there is some. And some of that is like, modifying and selling pelts. A lot of it's traditional use. But that's a fairly small area where that is allowed, and it's whereas in Canada, there's not really much opportunity for that. It's prohibited. Same thing in the lower 48. It would be a massive battle to have a management system that's similar to what they have in places like Alaska. But again, not a governance or legal expert. You'd have to ask those folks. It's just in this case, it's a challenge because there might be natural recolonization. They expand very slowly. They're not up here because they get eaten by sharks as they try to go north of San Francisco Bay. But there are conversations about restoring them to Oregon and California. And the hard part is, if there's no management options, how do you do that, right? Because traditionally they would have been managed in some way by coastal people.
Well, that's what I was going to ask you. What's prevented them from coming up to Northern California, but it's sharks?
Yeah, they get eaten. They try to go past the Farallones, is my understanding, and they get eaten. The same thing right now. They're in Elkhorn Slough in near Monterey, and they get hammered. So they're really hanging out in that space. So really, it's a predation problem, as far as I understand. That doesn't mean they, one might not make it, but they had been other areas. They had been translocated. So the really crazy story. The reason sea otters got moved over different places from the Aleutian, there was a relic population of the Aleutians. People were nuclear testing, and it turns out that if you go underwater and hold your breath and there's a nuclear weapon that's exploded, the pressure wave will explode your lungs. And so they had to translocate the otters to somewhere else, and it turned out that was a massive restoration effort to other places, and that restored kelp forest in British Columbia and other places in Alaska. So they had this historical, but I think there was some failed relocation efforts in 1980s, yeah, and in Oregon, and there hasn't been any relocations since that time.
Referring to traditional management, do we have a sense of the evolution of the ecosystems over thousands and tens of thousands of years back to the last ice age?
Yes, there's archaeological records from, actually, even from San Francisco Bay, where there are otters. But in the Aleutians, the peninsula off, where you can see, where Sarah Palin can see her house, if you know, from Russia, there are archaeological bins showing booms and busts of sea urchins in a lot of those spaces. And there is a lot of evidence of, including kind of traditional stories of how people would have managed, say, clam beds, where they might have hunted an otter, again, put it on a pike, stuck it, and had it basically as a scarecrow, as well as hunting and different methods. So there's a lot of different management alternatives that people had used that were basically perceived to be fairly successful, as well as the examples in Alaska. But those management options, that was 200 years ago when a lot of those animals were extirpated. So you're dealing with a loss of memory, and a lot of that from stories, archaeological bins, and other records. Yeah.
Was there any kind of campaign to try and teach people, change their eating habits? We can live our lives without eating an abalone or other fish and.
Yeah. So I think the hard part is for a lot of the communities that work with, this is a cultural it's a spiritual food, and there's a lot of opportunities for sustainable fisheries in these spaces that are that if managed well, right? I showed those images of just piles of abalone, and we see the same thing with oysters. We see the same thing. It's the massive. There are sustainable options for thinking about the scale of these, and so that's the question: is whereas for us, right? If you're eating an abalone at a sushi restaurant, that's a different experience than somebody who's got generations linked to, it's the art associated with the shells. If you listen to, we had some of these events, and you talk to some of these people, and I don't think you'd want to take that away from those communities in that area. But in places like Haida Gwaii, there is a moratorium, so they've lost that cultural access because of the Western overfishing. That even though there's recovery now, there's still a moratorium for them for that traditional resource. So also it's they are in some of these places quite abundant, but a lot of the areas that we work, people are abiding by these moratoriums because they do want to have recovery of these species until there's abundance.
Right. So now that we're crossing over, let's say, I really want to understand, given that there is not that much left of the abalone and the sea urchin population, how much impact will the economic demand be in terms of, let's say, if I want to buy urchin, how much will it cost me, let's say, a consumer, if I want to buy one of those? Because the economic impact of it becomes a question of, am I going to cover for things like environmental impacts? Am I going to cover things like how much will it cost to transport that limited amount, and so on?
Yeah, so a couple of things. The first is that with sea urchins, there's quite a few. The problem on our coast is there's too many, there's not enough food, and so they're not actually producing enough roe on the north. So the urchin fisheries collapsed on the north coast. Those guys are fishing in Alaska and they're fishing in Southern California. The price is quite good, and that's quite a sustainable fishery because it's fairly small in terms of scale. It's a niche market. It's very unlikely that there's ever going to be a commercial abalone fishery on this coast again. What the Haida and others are talking about is more of a traditional personal food, social, and ceremonial use, which means a relatively restricted harvest policy. What a lot of people are moving towards is more an aquaculture scenario where, so the French and other areas, most of their ormeaux, which is the French abalone, those are grown in cultivation spaces similar to what you would have for oysters. And so that's, if you want a commercial market, you probably need something that's a little bit more on that scale. But the urchin fishery is quite lucrative, but most of that fishery is now in Southern California, places in British Columbia and Alaska, and it used to be big here. A lot of the urchin harvesters from Northern California are now working on restoration projects, actively removing emaciated purple urchins. So they're being paid for approaches like that seem to be working on really small scales. Just because you can restore a small bay, but it costs millions of dollars. You have to do it every year. Yeah.
Another traditional food issue in Haida Gwaii is that I think it's particularly outsiders have come in and established big fishing lodges. And so that the tourists can come in and stay at the fishing lodges. One issue is they stay at the fishing lodges, they don't actually go into the Haida communities. And then the Haida feel that these people, these visitors are coming and stealing all their salmon. So that is another big issue up there.
Yeah, it's a thorny issue. It's a place that has a long history of colonial legacies, and those are, maintained today through relationships with, outsiders. So it's a hard one to navigate. Again, that's a governance issue. I won't comment on it, but it's a challenge in those spaces. Yeah. Especially when you're thinking about harvest policies that get more to is a lodge a commercial fishery?
So you mentioned just now government or governance issues. In California here on the North Coast, what agencies are involved, government agencies? The Fish and Wildlife, what other agencies are?
Yeah.
And do you feel they're working with you, or what's the challenge?
Yes, we collaborate with Cal Fish and Wildlife, some of the biologists there. It's a, trying not to get myself in trouble here. So a few groups that have an active presence, right? Cal Fish and Wildlife, the Nature Conservancy is actually putting a lot of money into kelp forest restoration. A lot of it is like paying fishermen to remove urchins, as well as outplanting kelps. Again, can be successful on a fairly small scale. At Big River and some other areas, there's some successful ones. We're collaborating with Kashaya on a restoration site in Shell Beach off Sea Ranch. On a fairly small scale to protect, say, a spawning aggregation of abalone can be successful. One of the real challenges is that the abalone harvest, the recreational abalone harvest in California, was quite lucrative for the state of California through licensing. There was the reason we know about a lot of these collapses, because Cal Fish and Wildlife was spending a lot of money on doing the surveys for a lot of these species. That's kind of over. We're in a budgetary crisis. Is that related to the lack of revenue from these different, there's politics, I'm sure. But we don't, you go to a place like Alaska, there's a lot of money that's spent on ADF&G, Alaska Department of Fish and Game, on surveys, on fisheries management. I think we're in a different space in California. We just it's not as important a sector. But there is a lot of effort and a lot of interest and a lot of private interest as well. And then on the sea otter side, there's a lot of dialogue with fishermen, with NGOs and other groups that are interested in the idea of understanding the potential for sea otter restoration. But it's a much more political, thorny issue that really needs a lot of exploring of what are the trade-offs and who stands to lose and who stands to benefit from those outcomes. So that's kind of a non-answer, but that's where I'll leave it, I think.
Hi, I have actually two questions. The first one is, what is your thoughts between actually removing from the environment versus just smashing? Because smashing would take a lot less time, I'm assuming, right?
It is way more efficient to go through and smash the animals. In Haida Gwaii, that was one of the choices that was used. Again, that was a Haida-led project, and that was kind of one of their choices. In Northern California, a lot of the tribes, at least the tribe, Kashaya, for example, have decided that that's not something they were interested in, so they've been paying to harvest. Again, if your interest is in protecting a bay, that's something you can do with paying the harvesters to do that. That's an ethical question. It is way more efficient to smash an urchin, but it's a different, not up to me.
The second question is, you're talking a lot about the restoration of the sea otters, but is there just as much effort put towards the restoration of the sunflower sea stars, because they were the original predator to begin with, and that's how our ecosystem has evolved?
Yeah, so two things. The first is that when we did a lot of work on this in British Columbia, central coast of British Columbia, what we found with the sunflower stars was most of the evidence was pointing to that they were influencing the smaller size classes of the big red urchins, and it's the sea otters that get the big ones. And you do a lot better if you have both, right? Because the sunflower stars eat the little ones, the sea otters just go crazy on the big ones. They don't like smaller urchins.
And they don't like ones that are emaciated either, right?
No, but eventually they get fatter when the sea otters come in. Because when you go to these areas where the sea otters have come in, regardless of whether they are emaciated or not, there's only a handful of urchins under rocks, and they are terrified, and there's very few left. So in Monterey, that's what they're finding is the sea otters are staying away from the emaciated urchins. But we call it a feed line. There's a new layer of urchins that are right next to the kelp that are just eating, and so they're just skimming the cream off is kind of what people are thinking in that area. And because why would you eat something that's empty when you have another meal over here? So the sunflower, there's a lot of groups that are interested that are trying to do captive breeding of sunflower stars. And but a bright note is that you go up to Mendocino and a lot of these areas, we're starting to see some new natural recoveries, 10, 12 in a bay here and there. And in British Columbia and Alaska, there's actually a lot of them coming back.
Weren't there 5 billion that were lost?
Billions,
so,
yeah.
I can't imagine.
No, and so the hard part is that a lot of people have focused on, it's absolutely worth the investment in that active restoration. It is really hard to restore an invertebrate. People have been trying to do this with abalone. And active restoration of things like white abalone is a really amazing program. It just takes a lot of money, a lot of time, and a lot of effort. But when you have nothing else going, that is like absolutely put your money into that space because it's an incredibly valuable opportunity. It's really hard because these animals put their eggs out and they go forever away, right? So it's not like they stay nearby and you can restore that bay. It's a long game for doing that. So I think for sunflower stars, people are thinking, whatever we can do, it's a really valuable investment, but it's going to take a lot of money and a lot of effort.
How do you think ocean acidification is going to impact this problem as that progresses? It seems like this was temperature driven, and now we have this other issue. What will be the impact there?
Yeah, one of the interesting things, we did a lot of work, and we're still working on efforts on thinking about like what are the impacts of ocean acidification on these organisms. One of the things we found was that number one, the present day extremes, a lot of them, at least for the urchins, are very much driven by the temperature constraints. Now for other species like oysters, it's a bigger issue. They're growing oysters in Hawaii now because a lot of those bays are incredibly acidified. But when we would simulate, expose these animals to kind of present day extremes, they wouldn't do great, but they would do pretty well. The big thing was like they would eat a lot more so the way the nerds for calcification, they have to maintain an internal pH, and so if there's a different pH, they basically have to get that pH back to 8 point something, and it takes a lot of energy to basically have an internal differential, and so they can do it. It's like a lot of work, right? So we're not at that point, but there are these. It's a complicated issue, and different species are going to have different outcomes, and it's complex. And we get hot spots where there's upwelling. So it's much more complex. The marine heat waves come fast, and they have had just empirically a dominant impact on our coast here from a sustained outcome. But it's all a problem.
You mentioned middens. From middens, do we have any evidence that these sort of environmental changes, either acidification or temperature, have happened in the past?
It's a hard one because so one of the interesting things about like middens and a lot of other things is you can actually try to reconstruct temperature from bones. Oxygen isotopes, basically you put things through an instrument and you can detect what's the ratio of this one molecule versus the other, and you can try to reconstruct historical temperatures. We also know that things like, we've had colleagues that worked on Pacific herring and little herring bones, and we can see large fluctuations, but we also see that things used to be much more stable. The hard part with a lot of these animals is urchins don't preserve very well. So you can find a little piece, but they kind of fall apart. But it's a really important legacy of being able to utilize those, but in collaboration with the communities from which they came. So it's kind of more sensitive on that point as well. So we're kind of moving away from just going out and digging up things rather than Berkeley actually had a really bad legacy of a lot of those. So there's some cultural sensitivities associated with those as well, because you are digging up other people's, business. But yeah, it's a great resource, and I think people are starting to explore that much more. It is challenging.
Thank you. When you mentioned the thing about urchins falling apart, they have that crazy beautiful pattern in there. Like, what is the reason for that, or why? Like, do you know what that's?
Yeah, they have growth plates. They're called ossicles, and they're basically glued together. And so, if you ever go out and you have an urchin test, that's the skeleton, and you basically get rid of the connective tissue, they fall apart. It'd be the equivalent of your femur disconnecting from your knee and your tibia. So that's their growth form, and they have little holes, and that's what allows them to have their tube feet, these pneumatic devices that have glue on the end. And they're wild, weird creatures, and they basically have little spines that are glued to those things as well. But yeah, the ossicles come together, but they're delicate, right? If you want to preserve an urchin test, it takes a lot of work to just kind of keep it clean.
So as it grows, it creates more of those cells.
They expand.
Okay, so
Yeah, so you can, if you inject them with tetracycline, which is the antibiotic that they used to use that turned out would stain our teeth if you shine a black light at it. We inject them with that tetracycline, and we can come back a year later and find out how much they grew, which is kind of cool. Yeah.
so just two things that I don't know so relevant, but one of the problems with the abalone is all the poaching. The Coast Guard doesn't have a lot of people, it doesn't have a lot of ability, because it's a big coast, but they've found quite a lot of poaching, and it's boats that come over from China, or maybe they're filled with Vietnamese sailors, but they're all from China, and they're poaching the abalone like massively, and then so there's not a lot of enforcement. I'm wondering how effective that is.
Yeah, Cal Fish and Wildlife used to have basically, I can't remember what, the fellows that would just sit on top of the cliffs with binoculars, and you would get nailed if you were taking more than your allotment. But I would say it's not just foreigners. A lot of locals get caught with their van full of abalone driving down the street. So I have no knowledge of what the ratios are, but I do know you get reports quite frequently of Californians getting busted with. So poaching is an issue, especially for red abalone. It has been an issue for different species, northern abalone in Canada, but it's a bit of a sensitive issue because during COVID, that's when actually, because of the lack of enforcement in certain areas, that's when some of the poachers came into some of those spaces. But in a lot of these areas in Haida Gwaii, there are guardian watchmen that have cabins, and they kind of have a pretty good lookout in some of these spaces. So that's one of the benefits of some of these programs, especially Guajanas, that has, a different kind of operation. But the poaching is an issue, but we lost 90% of the abalone from basic pure starvation, right? So the proximate cause associated with the demise in recent years with red abalone was the marine heat wave, lack of food, and they just got demolished. I mean, they are just literally a walking bicep that needs to eat all the time. And if they don't have any food, they will starve. So the poaching is an issue, especially now that we've seen very few new babies coming into these populations. We've been monitoring, and there's basically nothing. They're not reproducing, they're not recruiting. All we're seeing that's left are the ones who survived. It's a really sad problem.
Getting back to your zombie sea urchins, the question is about their resilience and their incredible longevity, and you mentioned research at a cellular level. My understanding is that in terms of a vertebrate group, they're more closely related to us than any other invertebrates at a cellular level. So I'm just wondering about anything that you've discovered in terms of relationship to human longevity. Not that I want to become a human zombie.
No, but wouldn't it be great if you could just Also, they can go on this magnificent diet and still look great. No, so it's they are deuterostomes, so we use them as a developmental model for they do very similar things that when they first get fertilized and how they form at that stage. So that's a similarity, but they are, you draw the tree and they're way back there. But there is a lot to learn about organisms that can live in extreme environments, right? Why is it that a seal can dive to a couple thousand feet and go to very low oxygen concentration? We would be toast, right? Those kind of things can help us learn a lot about what is it that allows for cellular recovery and repair or survival in those spaces. And this is very early in a lot of this work. Also, NIH is getting gutted, and so it's more difficult. We were just starting to write grants on some of these things when, not a political talk, but we need more money in science.
What else do abalone eat besides kelp? And have you thought about bringing in other predators? Can they find them from anywhere else in the world?
The other predators one. The Australians keep trying that, or kept trying that, and kind of got them in trouble. There's not really any other. So there are predators in Southern California, There's sheephead, which have been historically fished, spiny lobsters. So the non-sea otter predators of urchins are mostly in Southern California. There are a few others that go up to Monterey and things like wolf eels, but nothing. The reason sea otters eat so many urchins is they don't have any blubber and they have this amazing fur, but they basically burn hotter than any other marine mammal, and they just are a giant furnace. They'll eat like 30% of their body weight a day because they're just like dumping heat into the ocean. If you put a FLIR, a thermal camera out, you can spot them from anywhere because they pop because they're just burning. So that's part of why they are like a voracious predator. So to control the urchins, I mean, we are also incredible predators. So that would be the only invasive predator that I would say is like introduce more people to the problem, which is kind of what we've been doing. But there's not really another solution because any of the other predators that exist naturally in that system, the pinniped, so the seals and sea lions, they eat fish. They don't care about an invertebrate. They're not really designed for that. So yeah, it's really, I mean, you could get a bird if they're in the intertidal, but and river otters, but for the most part, the divers, that's the dominant predator in the system. Now, there are a lot of places that don't have urchin barrens that don't have sea otters. So it's not a 100% scenario, but in the areas that are, that is the dominant species that's going to have the reversible outcome anyway, until there's a disease. Diseases do wipe out massive amounts of urchins. So a lot of people said off the coast of California and Oregon back in the, 60s and 70s, some of you guys remember, apparently they used to be in abundance and they got wiped out by a disease as well. This is all hearsay. I have no direct knowledge or evidence of that.
Well, I also asked, what do abalones eat besides?
Oh yeah. So abalone, they're so it's really interesting. In Haida Gwaii, this is something we're working on. In Haida Gwaii and other places, the small individuals actually do fine without kelp because they basically are fine eating scuzz. It's when they get big and they get hungry that they start really needing kelp. Kelp doesn't actually have a lot of protein; it's all sugar. So they also eat things like red algae, so nori, that we eat around sushi. We have a native handful of species here, heavy in protein. So they eat a lot of other things like that. Dulse, yeah. So and they'll just scrape scuzz off the bedpost.
Oh yeah, what are the diseases that attack the urchins? And is there anything you can, instead of smashing them?
Yeah, it's Vibrio is one of them. So Vibrio is like, one of the things that might make you sick if you eat an oyster. That's a similar species is the one that wiped out the sunflower star. So the problem with introducing a disease is like, you better know what you're doing.
So the thing that makes the sea urchins survive without starving, how common is that in other things? I think I understand that snails have the same ability. The invasive garden snail that we have now can last years without.
I don't know about the invasive garden snail. I would have to look into that. But there's a variety of others. The thing that makes urchins special is they just, like I said, they don't have a lot of the structures that are energy consuming, right, are the ones that are muscular protein that has a lot of mitochondria, the little energy consumer in our bodies, and they just don't have a lot, right? So the gonads, the uni that I was showing you, that's all fat. And if, you guys know about, like, you go to the doctor and they're like, well, you want to burn more calories, you got to put on more muscle, because like we just don't, the fats don't have a lot of mitochondria. They're a really good energy storage organ because they don't use any energy. And so urchins they can metabolically depress themselves by, they can shut down, they basically go into a state of torpor, and they don't have a lot of stuff that needs to be maintained. But a lot of other animals do that. Like there's insects that will, there's a reason why you can get these animals that have, 17-year cicadas and a bunch of other species that can go into a state of torpor. Same thing in the winter time. So there are a lot of organisms that have similar capacities. This is just a remarkable flexibility to respond to food deprivation in a way that is different than a lot of those other life cycles. It's kind of why this is a pattern we see with urchin barrens. We don't really have barrens of a lot of other species because it just happens to be they're just a walking, food bag. And they're pretty efficient.
I know that what we call the southern sea otter came back from just a remnant population that they found near Big Sur.
Yep.
Back, I think, in the 1930s. They got up to about 2,500 animals at the time when we had an organization called Friends of the Sea Otter. And since that has gone, it's sort of amalgamated with another. I haven't heard what the numbers have gotten up to. Have they gotten any better?
Yeah. So the thing about sea otters is we think about this idea of like, you know, they just exploding. The females make one pup a year. And when you start with a fairly small population, it just tends to be, they kind of grow slowly over time. And they tend to hang out in an area until there's kind of critical mass, and then a bunch of males will go out and eat a bunch of stuff. So yeah, they've been growing. They kind of go through these like stagnation periods. We collaborate with a bunch of the folks like Monterey Aquarium. They would be able to answer this question better than you. We study the things they eat, not the animals themselves. I don't like dealing with permits for vertebrates anymore. But yeah, they're expanding, but up to the line of where they're getting hammered by sharks on the northern side of the range there.
I know they tried to put some out on the further Channel Islands.
San Nicolas Island.
Yeah.
So San Nic, they've been slowly increasing in numbers. Again, it wasn't very many that they put out there.
A lot of them swam back, I understand.
Yeah, a lot of them swam back, but now there's an established population that's like just very slowly growing over there, and they're, you know, having a little food party, eating urchins very slowly.
So the numbers are going up, but
Slowly.
just slowly.
Yeah.
Yeah, because we were afraid they'd be just basically one good oil spill would have taken out that population when it was.
They stopped trapping them and moving them back.
Right.
So there was an active effort to like trap them anytime they'd escape and put them back. The U.S. Fish and Wildlife Service was doing that, but I don't think they're doing that anymore.
As you discuss each organism, you repeatedly mention how it uses energy or its energy characteristics. Do you do any research or any presentations where you treat the energy flow as the primary thing that you're discussing rather than megafauna?
The energy flow, you meaning in which part? Like the food? Yeah, so a lot of... Yeah, so we think a lot about energy flows. Some of what we do is we build things called energy budget models, which is the idea of like, okay, how many calories are you using? How is that allocated to growth versus reproduction? How does that impact how you acquire energy? How does that flow up the ecosystem? So yeah, we do a lot of that. It's really hard to measure in the field, but so a lot of what we do is like try to measure that from a physiological perspective in the laboratory, and then make assumptions about how that translates out in the field. It's kind of like, again, you measure an athlete and you're like, well, they're running 200 meters. This is what we think they're doing based upon what we did in the lab. It's the best we can do in that space, yeah. But it's really dynamic because it's the balance, again, between consumption and production is all dependent on the environmental conditions, how many individuals are there, and that's really what tips this space from highly productive to devastating.
Is there any connection between the warming waters and the decrease in oxygen level with what's going on with any of these organisms?
Yeah, so one of the things that happens with coastal upwelling is we get deep water that tends to have lower dissolved oxygen associated with that. So even though colder water holds more oxygen, we also get spaces where we get low pH, so high acidity, cool water, and low dissolved oxygen all happening at the same time. So it's more of a...
It also brings up the nutrients, so the oxygen explodes right away.
It can, but if it's basically a pump, so a lot of those organisms, based upon some of those upwelling events, can get really devastated. But then there's the eutrophication problem in places like the Gulf. Yeah, the dissolved oxygen thing it's a bit more of a stochastic mess that is also hard to deal with because it's stochastic, unpredictable. But it is another issue in that space, especially you can have mass die-offs of animals just from these pulsed events. All right, thank you very much.
Really let you get to your last slide?
Yeah, actually.
Right. I am so impressed by your questions. Thank you for being here. How about a final round of applause for our speaker, Dr. Dan Okamoto.